Alright, so let us continue with the topic for divisibility. So earlier, to check if a number or an integer is a composite or prime, we need to factor the number. Now in Euclidean algorithm, it would be different. So in Euclidean algorithm, we need to find the greatest common divisor. So by recursive use of the division algorithm, we may find the greatest common divisor of two positive integers a and b, GCD AB, without factoring either. So this procedure is also known as the Euclidean algorithm. So let's recall that the greatest common divisor, or the GCD, is the two integers a and b is the largest integer that divides both a and b. So in the Euclidean algorithm, it is a technique for quickly finding the GCD of two integers. So always remember that a and b is not equal to 0. So example of Euclidean algorithm. So let's have first the given number 84 and 104. So let's put 104 as our dividend and then the 84 as our divisor. Now in this one, 104 divided by 84, we will be getting 1 as our quotient, and we will have 20 as our remainder. Now since it was not yet 0, so we need to continue the process. So the second solution will be 84 as our dividend, 20 as our divisor, since that is our remainder earlier. Now if we solve it, we will be able to get a quotient of 4 and a remainder of 4. And since it was not yet zeroed, so we need to continue the process still. So another solution will be 20 as our dividend and 4 as our divisor. Now once we process this one or solve this one, we will be able to get a quotient of 5, meaning there will be no remainder, so it's 0. So meaning we are done with our process. So we are able to get the greatest common divisor, which is the 4. Alright, another example. So let us try to find the GCD of 1785 and 546. So again, let us have here the dividend as 1785 and our divisor as 546. Now in solving this one, we will be able to get 3 as our quotient and 147 as our remainder. And since it was not yet zeroed, so we need to continue. So on the next step, we will be using 546 as our dividend and 147 as our divisor, and we will also get 3 with a remainder of 105. And since again it was not yet zeroed, so we need to continue. So this time around, 105 will be our divisor and 147 will be our dividend. Now the quotient will be 1 and the remainder will be 42. Since it's not yet 0, so we need to continue. Now we will be using 105 as our dividend and 42 as our divisor. Now we will be able to get 2 as our quotient and 21 as our remainder. So still it's not yet 0, so we need to continue. Now this time we will be using 42 as our dividend and 21 as our divisor. Now if we solve this one, we will be able to get 2 as our quotient and 0 as our remainder. So therefore our GCD in this one will be 21. Why? Because just like what I've mentioned earlier, it should not be 0, or it will not be equal to 0. So that's why the last remainder that we have is 21. So this will also be our greatest common divisor. Alright? So that's the end of Euclidean algorithm.